Let's walk you through problem 58 on page F of Physics 1141. This problem reads, when a magnetic north pole with a strength of 50 units is placed 2 centimeters from another magnetic pole, it experiences an attractive force of 1,500 dynes. What is the strength of the second pole? So this is similar to problem 57, which is in your solution key at the back of the score key. But let's see what we know here. We know that M1 is 50. We're asked to find M2. The distance is 2.0 centimeters. There is a decimal here. And then the force, I wrote 450. That is wrong. All right, let me, while we're doing this here, cross that out. It is 1,500. It's right here, Mr. Anger. Okay, 1,500 dynes. Now we're asked to find the strength of the second pole. Notice the strength is just in what's called units, okay? So in our final answer, we're just going to write units. This formula, which is presented in the PACE, looks very similar to the formula we used in the previous PACE, where we had Q1 and Q2, right? And in this case, since we're working with dynes, the K value is also 1.0, so that's helpful. If we take this formula here and multiply by the R squared on both sides, then it cancels out down here, and we end up with F times R squared equals K M1 M2. Then we're going to divide by the K in the M1 on both sides, and that will help us solve for the second M value. So we end up with this formula here, M2 equals, and here you go, you have the formula. And I'm not going to take it any further. I'm going to let you plug in all the numbers that are up here in this problem. Don't forget that K is 1. And again, remember to multiply this all together, and then multiply these together, and then take the two answers and divide them. Calculators can mislead you if you just blindly start plugging in numbers, okay? But this formula is an important one, and we're going to use it on most of the problems on this page.